So this lesson we're going to focus on scientific notation. Now, why is it that scientific notation is necessary? Now, if you think of how many liters of water there are on Earth, the number is actually quite huge. And in fact, it's this figure right here. And if you wanted to pronounce it, it's 1 sextillion, 220 quintillion liters. And as you can see there, that's a lot of zeros. Now, if you're writing an essay and you'd either be writing this figure repeatedly like this, or these words here repeatedly as well, if you ever had to mention the amount of water there is on Earth. Now, this could be pretty problematic because what if you accidentally missed a few zeros or you added too many zeros? You'd have to keep counting and it would just be a complete nuisance. Now, if you look over here, we've got a 1-carat diamond, and what is the question here is how many carbon atoms are there in a 1-carat diamond? Now, if you didn't know, diamonds are made of pure atoms of carbon. So if we just look at how many atoms make up a 1-carat diamond ring or 1-carat diamond, this would be the figure here. And once again, it's a really, really big number and extremely hard to say. Now, there are things in the scientific world that's really, really small and also really, really big. Now, one of the things that are quite small is the diameter of a carbon atom. Now, can you imagine what the size of this would be? It's estimated that the carbon atom is approximately this figure here, or we can say 70 picometers. But my point in going through this is to let you know that numbers can be very, very big or very, very small, and it would be a nuisance to write them with that many zeros or that many numbers. So that is why scientific notation plays a very, very important part in making our lives a little bit easier. So what is scientific notation? So it's an easier way to represent the very big and very small numbers that we saw before. The rule here is that we convert the number, convert it to a number between 1 and 0, then we multiply it by 10 to the power of however many zeros or decimal places we've moved the decimal point. So if that sounded confusing to you, I'll go through it with you right now. So numbers such as this number here, this really, really big number here, we've got 149,600,000. So it's quite a big number. We could write it by moving the decimal. So the decimal will be at the end of the number here. We move it until we get to a number between 1 and 10, less than 10. So here we've got 14.9, that's no good. We jump it once more to get 1.496. So as you can see here, we've gotten a number that is between 1 and less than 10. Then we multiply it by 10 to the power of the number of jumps that we've just made. And it's going to be a positive 8 because we're multiplying this. It's a really big number, so the power here would be positive. Okay, so basically, instead of writing this number here, we can write it in scientific notation and it represents exactly the same thing, but it makes it easier to write, especially if this number was even bigger. Now going down here, if you look at this example right here, this is a small number. So the aim of to write the scientific notation for this, all we have to do is move the decimal point, and this time we're going to move it in the opposite direction to make a number between 1 and 10. So right now we've got 0.2, so that's no good. And here we've got 2.31, and that is a lot better because that's what we're trying to achieve, a number between 1 and less than 10. So we've got 2.31, then we go times 10, and then we raise it to the negative power of how many jumps we've just made. So we've made 3 jumps to get it to that point. So scientific notation and the basic numeral that you see here are the same, except it's just a lot easier to write very big numbers or very small numbers using this method. So let's go ahead and see if we can write these numbers as scientific notation. So this is a really big number, or it's considered a big number, and we're going to move the decimal point this way, so to the left. 1, 2, 3, 4, 5 times. So I've got 7.2, and that's what we want. We want a number between 1 and less than 10. Then I'm going to multiply it by 10. To what power? Well, how many jumps did you make? 1, 2, 3, 4, 5 jumps. So it's going to be positive 5. Okay, so 7.2 times 10 to the positive 5 is the same as 720,000 up here. If you think about it, 10 to the positive 5 is the same as 10 with a 1 with 5 zeros. 5 zeros. There we go. So we're basically multiplying 7.2 by 100,000. So it's the same as 720,000. We've made no change other than make it easy for ourselves when we're writing big and small numbers. Let's do this next one here. It's a very small number, so I know my exponent or my index is going to be a negative. So moving decimal point back, 1, 2, 3, 4, 5, 6 times to get it to the number 3. So I've got a number between 1 and less than 10. Multiplied by, it's going to be 10, and because it's a small number, it's going to be negative, and I moved it 6 times, negative 6. Now we can go back the other way as well. We can express our scientific notation into a basic numeral. Now they say decimal form in the textbook, but what they're basically saying is just get it back into a number or non-scientific notation. So over here it says times 10 to the power of 3. So that means we're going to do what we did before, but we're going to move the decimal point 3 times to the right because it's a big number. Moving it to the right will make it bigger. So 1, 2, 3 jumps, and where there's an empty arch, you just fill it in with a 0. So my decimal point is now at the end of this number. So the number here is 6,170. Okay, that is the same as 6.17 times 10 to the 3. For B, we know that this is just by looking at it, we know it's a very, very small decimal number. And to write this back into the basic numeral, we just move the decimal place 6 times, and this time, because it's a small number, we're moving it to the left. 1, 2, 3, 4, 5, 6. Decimal point is here now. There's a 0 at the front, just so we know that there's a decimal point, and then we fill in the rest of the zeros. So I'm sure you can write this out in your own time. So 0.0000402 with a decimal point here. And there you have it.